Alright, so this is a Chapter 3 practice test. I'm having sun issues right now, so hopefully things are viewable. Problems 1 and 2 ask me to find the domain and the range, and they give me a graph. In problem 1, it's kind of a half a parabola on its side. Graph looks something like this, where the point 30 is labeled, but the right edge of the graph doesn't have a point. And so I have to assume that the graph is going to extend. So I'm going to put a little arrow at the end of the graph and assume that the graph goes down and to the right forever. So this is a graph that I need to extend. I need to extend the x-axis to its far right edge because the graph ends up at the far right edge of the x-axis, and the far right edge of the x-axis ends at positive infinity. And the graph is going down as it moves from left to right, so I'm assuming that eventually the graph is going to work its way to the bottom of the y-axis, and the bottom of the y-axis is at a negative infinity. So in some sense, this graph goes to the point positive negative infinity. I don't know that that's going to help, but that's kind of how I might think of this. So in terms of the domain goes from the x-coordinate at the left edge of the graph to the x-coordinate at the far right edge of the graph. The point 30 is going to be where I start my domain. And the point at the end of the graph is going to be the end of my domain. I don't really have to write a point there. I'm not sure that I did that in the videos, but just to emphasize that. Points on the graph when you write the domain and the range get marked with square brackets, so the x-coordinate of the start of the domain is going to be given a square bracket, and the x-coordinate of the point at the end of the domain is going to be given a round bracket. Infinities always get round brackets. Extensions of graphs always get round brackets. When I go to do the range for the same graph, I'm picking off y's, and I'm picking off the y at the bottom of the graph and the y at the top of the graph. This point, infinity, negative infinity, this is actually going to contain the start of my range because it's the bottom point of the graph. To do the domain, I'm working from left to right and looking at x's. To do the range, I'm working from the bottom to the top, and this point, negative, positive infinity, negative infinity, is going to be at the start of my range because it's at the bottom of the graph, and the end of my range is going to be at the top of the graph, and the very highest point in terms of bottom to top is going to be that point 30. So the point 30, it's the left edge, which is the start of the domain. It's the top of the graph, which is the end of the range. The point infinity, negative infinity, it's the right edge of the graph, so it's the end of the domain. It's the bottom of the graph, so it's the start of the range. When I go to do the range, I'm going to take the y-coordinate of the bottom point and the y-coordinate of the top point and write them in order. The bottom point has a y-coordinate of negative infinity, and the top point has a y-coordinate of 0. Points that are on the graph always get marked with square brackets. Infinities, or extensions of the graphs, get marked with round brackets. So that would be the best I could do for problem 1. There isn't any algebra to do, so it's hard to give you partial credit. In problem 2, it would be completely wrong to connect the points. These points are given as separate points, and they're not meant to be connected. When I go to write the domain and the range for it, I'm just going to pick off the x and the y values. So when the points are scattered, the domain is usually written with these squiggly set braces. Similarly, the range is normally written with these squiggly set braces. And both the domain and the range are going to be just points from the graph. The domain is going to be the x-coordinate of each point. So I see negative 3, 0, 2, 3, and 5 as the 5 different x values. They can go in as any order, but I need the 5 different x values that occur from the 5 different points. That would be as good of a domain that I could write. Domains are x's. When points aren't connected, you need all the individual x's, and your order could be different. You could have wrote 0, 2, 3, negative 3, 5. Whichever order you write is up to you. The range is going to be the y's, and when I look at the points, there's 2 points that have a y as 1. I only need to have each individual y in my range. I don't need to put 2 1s. I need to only put 1 1. Similarly, 2 points have a y of 0. I don't need to put both of those in my range, but I need to have a single 0. And the other y, the other unique y, is 2. So my range needs to have the 0, the 1, and the 2, which are the individual y's that occur from any of the points. And that's as good of a range as that I could write. When I go to do problem 3 through 5, this wants me to find a domain and a range using algebra. And in problem 3, to find the domain of a fraction, you ignore the numerator. So to do number 3, to find its domain, because it's a fraction, I'm going to ignore the numerator. Now that you can't see that, I'm going to solve the denominator equal to 0. And unfortunately, that doesn't give me the answer for the domain. It gives me the numbers that I could use in the words, or the numbers that will show up in my intervals for interval notation. So assuming that you can't factor this right now, I've recently written a program to help myself factor. So I'm going to run that program. I'm going to go program, quad, enter. A is the number in front of the x squared term, which is 1. B is the constant. C is the term without an x. When I run this, I'm going to change the signs on this program to get this factored. So x minus 1, the negative 1 is going to turn to a plus 1. The minus 2 is going to turn to a plus 2. So this is going to factor into x plus 1 times x plus 2. Because when I went to factor this, the signs are all plus, so I shouldn't get any minuses. The last need to multiply to 2 and add to 3. Once I have this factored, either factoring in my head or using my program to factor, I'll take the parentheses or the factors and set them equal to 0. And this will give me the numbers that are needed for my answer. Setting the factor of x plus 2 equal to 0 and subtracting 2 from each side, I get negative 2 as a number that belongs in the answer. Similarly, setting the factor of x plus 1 equal to 0, negative 1 belongs in the answer. There's at least 2 ways to write the answer to this. To write the domain in words, I'm going to include the numbers x equal negative 1 and x equal to negative 2, along with the words something like this. The domain as all numbers or all real numbers except these numbers. And I won't even write the x just to be lazy. This would be writing the domain in words. This would be completely fine on the test. If that's all you did is ignore the numerator, set the denominator equal to 0, and write the answer like that, that would be fine. The alternative would be to write my answer in interval notation. To get an answer for domains in interval notation for a fraction, it's going to be all round parentheses, and I'm going to get one more interval than there are numbers that the algebra produces. So I'm going to get 3 intervals in my answer, and in order to get the answer in interval notation, I'm going to create a number line with positive infinity on the edges, and the numbers in order, how they'd appear on a number line, that the algebra gives me between. And now I'm going to round parentheses all these up to exclude the numbers. Round parentheses exclude numbers, square parentheses include numbers. And I'm going to create intervals. The first interval I'm going to write is the interval from negative infinity to negative 2. And then the interval from negative 2 to negative 1. And then the interval from negative 1 to infinity. And in interval notation, the alternate answer is going to be the interval from negative infinity to negative 2, all round parentheses, and then a u, which kind of means or the next interval, then the interval from negative 2 to negative 1, and then another u, which kind of means or, technically means union, and then the interval from negative 1 to infinity, all round brackets. This is domain written in interval notation. On the test, you don't need to give both. You can give either the domain in words or the domain in interval notation. It's up to you what you prefer. Finding the domains of square roots and finding the domains of fractions are completely different than finding the domains of fractions. Fractions, you ignore the numerator, solve the denominator equal to 0. The answer that the algebra gives you isn't the answer, the final answer. To find the domain of a square root, you just set the argument, that's the stuff under the square root. I don't know if I could spell argument. I just take the argument and set it greater than or equal to 0. That's the algebra. The algebra for the domain of a fraction is you set the denominator physically equal to 0 as opposed to greater than or equal to 0. So the algebra for number 4 to find the domain of a square root is just to take the denominator and set it greater than or equal to 0, isolate the x. In this case, I'm going to isolate the x by adding 6 to each side. And then I can write this statement in words, or I can write it in the interval notation. If I read this, it says x is greater than or equal to 6. The algebra for finding the domain of the square root actually gives you the domain. So in words, I could say the domain is all real numbers, but not the word except now anymore. It's just going to be greater than or equal to. So that would be the domain written in words. And then in intervals, in terms of a number line, this means any number starting at 6 and getting larger, I'll put a square bracket because they are equal to, and bigger than 6 is to the right. And the interval notation for the domain here would just be the interval square bracket on the 6, round bracket on the infinity. Infinities always get round bracket. And this would signify the numbers that are bigger than or equal to 6, starting and including 6 with a square bracket, and going off to infinity, which is the numbers bigger than 6. So fractions, you ignore the numerator, set the denominator equal to 0. The algebra gives you the numbers that belong in the domain, but they need some tweaking, especially if you're doing interval notation. Square roots, you set what's under the square root greater than or equal to 0. The algebra actually produces something that's an acceptable domain. It's not technically in words or interval notation, but doesn't really need the same sort of modification. Number 5, this is a polynomial. There's no algebra to find the domain of a polynomial. It's not a fraction, it's not a square root. If I put this on the test, which I normally don't, if I give you a problem that's not a fraction or a square root, the domain's all real numbers and there's no algebra. I take that back. I think I regularly put this on the test. So for this, the domain is just going to be either in words, all real numbers. So I can say the domain without any except, without any greater than or less than. Without any except, without any algebra. If you do any algebra, you're messing up. If the problem's not a fraction and not a square root, on this test, it's a polynomial, and polynomials have domains of all real numbers. And the option of doing a domain in interval notation is just writing the interval from negative to positive infinity. And both of these would be acceptable answer. The instructions say you only need one form of this, so whichever form you feel most comfortable with would be fine. All right, now it's just some function notation. Problem 6 wants me to use the functions f and g and find f minus g. So what I'm going to do is just solve the problem. The parentheses here doesn't mean to multiply by x. It looks like it says to multiply by x, but it doesn't mean to multiply by x. It just means don't change the x to another number. When I go to do this, I'm going to put two parentheses separated by a minus sign. On the left side of the parentheses, I'm going to place what f is equal to, and on the right side of the parentheses, I'm going to put what g is equal to, and I'll put the minus between. F of x is equal to 2x plus 5, so in the left parentheses, I'm going to plug a 2x plus 5. G of x is equal to 3x minus 1, so in the right parentheses, I'm going to put a 3x minus 1. Now all I'm going to do is do the algebra to drop the parentheses, combine like terms, and stop. The first parentheses that I put in really wasn't necessary because there isn't a negative sign or a coefficient in front of it, nor is there an exponent outside of it. So the first parentheses I'm just going to drop. The second parentheses has a minus in front of it. When parentheses have minuses in front of them, I need to change the sign. So I'm going to change the sign of the 3x to a minus 3x and the minus 1 to a plus 1. Now I'm going to combine like terms. I'm going to take the 2x and minus the 3x and get minus 1x. and then the plus 5 and the plus 1, and get plus 6. So this is kind of my answer. Probably wouldn't need to write the negative 1 in front of the x. And I can or can't, depending on what I prefer, write the original problem with the answer or not. Probably the nicest answer would say f minus g of x equals negative x plus 6, putting the problem with the answer and not putting the negative 1 in front of the x would be best. But it would be equally okay if you just wrote negative 1x plus 6, didn't write the problem next to the answer, and left the negative 1 in front of the x. What would be wrong to do is to take this and set it equal to 0 and solve for x. I'm moving kind of fast because I have a new video editing software that I don't know how to use. I'm trying to get this whole video on one part without the video breaking. So 7 wants me to find g composed with f of x, and remember that means g of f of x. And what that means to do is it needs to replace the x in the right side of the g function with the right side of the f function. So I'm going to find Goff, and what I'm going to do to find it is write the right side of the g function, which is 3x minus 1. I'm going to put a parentheses where the x was, and where that x was, I'm going to put the right side of the f function. So whatever function is written second, that function's going to go in place of the x in the first function. The x in the first function was preceded by the 3. I wrote that g function without the x, and inside the parentheses, I'm going to put the f function. That's all this tells me to do. It says take the g function and replace the x in it with the right side of the f function, and then just do the algebra to combine like terms. Here I'm going to clear this parentheses by multiplying by 2, the 3 by 2x and the 3 by 5. And then I'm going to combine the 15 and the 1, and I'm going to get my answer. It would be nice if I wrote the problem with the answer. But if you just wrote 6x plus 14, that would be completely fine. That would be the answer to number 7. Number 8 has a number in the parentheses, and that means to change the x to those numbers. I'm sorry, I'm recording this video, the better part of 2 years after I did it originally, and I peeked at all the algebra I did, and I forgot the algebra that I did here, so I'm just going to do this fine. This f plus g of 2, if this is a little bit different than the video, I apologize. There's 2 ways to do this, and I can't remember which one I did. So f plus g of 2, all I need to do is go to the f function and plug 2 in for x, and the g function plug 2 in for x, and then add the results. So I'm going to do that right now. I'm going to take 2 and plug it into the f function. That's going to give me 2 times 2 plus 5. The plus that's between is this plus here. Then I'm going to plug 2 in for the g function, which is 3 times 2 minus 1. And the f function, you get 4 plus 5, which is 9. And the g function, you get 6 minus 1, which is 5. And so when I add those two together, plugging 2 into the f function and getting 9, plugging 2 into the g function and getting 5, I get 14. The answer to number 8 is going to be f plus g of 2 equals 14. But I could just write the number 14. I don't need to write the problem along with the answer. If this is a little bit different, ask me in class and I'll show you the alternate way if you can't figure out the alternate way. 9's a big deal because it comes up in calculus. It wants me to find the difference quotient, and the difference quotient is this ugly fraction that has function symbols in the numerator and the letter h in the denominator. What I'm going to need to do, I'm going to need to replace the f of x plus h, and the f of x that's in the numerator with symbols, with something that's equal to those that doesn't have the function notation. For the f of x plus h, I need to take the f function and change the x to x plus h. So to figure out what I'm replacing f of x plus h to with, I take the function that's given and I change the x to x plus h. And that's going to give me f of x plus h after I simplify it. So f of x plus h is going to be 2x plus 2h minus 3. I get that by just changing that x to x plus h and simplifying. The f of x in the numerator I'm going to replace with 2x minus 3. So to find the difference quotient, I need to replace the f of x plus h with this 2x plus 2h minus 3. I need to replace the f of x with 2x minus 3, and then I need to combine like terms. To be safe, the stuff that I'm changing out in the numerator, I'm going to put in parentheses. The f of x plus h, I need to put something in place that doesn't have the function notation, and that's going to be 2x plus 2h minus 3. The f of x, I need to put something equal to f of x that doesn't have function notation. That's 2x minus 3. So this is technically the difference quotient. All I'm going to do is get rid of the parentheses, combine like terms, and simplify. The first parentheses that I placed in here I can just drop without any alteration, because that parentheses doesn't have a number, a sign in front of it, or an exponent. The second parentheses, I'm going to distribute the negative. I'm going to make it a minus 2x and a plus 3. Now in the numerator, I'm going to combine like terms. The 2x and the minus 2x will cancel. The minus 3 and the plus 3 will cancel. And I'll be left with 2h over h. And from there, the h's will cancel. And the answer to number 9, the difference quotient, is just the number 2. If you took calculus in high school, this has something to do with a derivative or the first derivative. Difference quotients are kind of related to something we do in calculus. Number 10 wants me to find an average rate of change. And an average rate of change is just the slope of a line that connects 2 points. So in problem 10, to do the average rate of change, I need to create 2 points. And these two values right here are the x-coordinates of the points. The average rate of change is just the slope of a line that connects 2 points. I give you the x-coordinates, and now I'm going to find the y-coordinates. The first y-coordinate, I'm going to plug in 0 for the x's. And the second y, I'm going to plug in 2 for the x's. If you can't do those quickly without a calculator, just use a calculator. Here I could just do 0 up arrow cubed plus 6 times 0 squared, and that's going to be 0. So the first y is going to be 0. For the second y, I can do 2 up arrow cubed plus 6 times 2 squared, and that's going to give me 32 for that y, just to save some time and make sure I don't make a mistake. So these are the 2 points. The average rate of change is just the slope, just y2 minus y1 over x2 minus x1. So in the numerator, I'm going to subtract the y's, 32 minus 0. In the denominator, I'm going to subtract the x's, 2 minus 0. That's just going to give me 32 over 2, which is 16. The answer to problem 10, the average rate of change, is just the number 16. It's the slope of the line that connects 2 points. 11 through 16 give me a graph, and they want me to find features of the graph. I don't know that this was showing up so great. Just so pinched on time here. So let me make this graph a little bit bigger. And I'll write the points in as I need them. So this graph is a parabola. It doesn't look exactly like this, but it looks something like this. For question 11, I'm asked to find the x-intercepts. X-intercepts are points on the x-axis, so I only labeled the x-intercepts here. Here's the x-axis. Any point on the x-axis, the point -1, 0, and the point 3, 0, are the x-intercepts. Those are the points I would need to do for number 11. For number 12, in terms of this graph, I need this point. Points on the y-axis are y-intercepts. I think that says 0, 3. So the point that I need for number 12 is the y-intercept, which is a point on the y-axis. So for each part, they're asking just for specific points or part of a specific point. The x-intercepts are asking for points on the x-axis, so I go across the x-axis. Any point on the x-axis is considered an x-intercept. Problem 12 is asking for the y-intercept. That's any point on the y-axis. Problem 13 says for what values of x is h of x equal to 4. That is only calling out this point right here. The number 4 that's given in this question is a y-coordinate because it's to the right of an equal sign. So there's lots of points on this graph, but this one is only calling out this point because it's asking me to find the x value of the point where y equal to 4. In function notation, numbers inside parentheses stand for x's, number to the right of the equal sign stands for a y. This is giving me a y equal to 4. It's asking me to find the x that corresponds to that. That's going to be x equal to -1. Problem 14 is calling out a point, and it gives me function notation again, but that function notation, the number that's given to me is in a parentheses, and numbers inside parentheses represent x's. So while problem 13 was calling out the point -1, 4 because it's asking me to find the x coordinate of any point that has a y equal to 4, problem 15 is asking me to find the y coordinate of any point that has an x equal to 4. So the difference in the points that they're calling out, this problem 13 is calling out a point that has a y equal to 4, problem 14 is calling out a point that has x equal to 4, and it wants the corresponding 5. Problem 14, the answer I'd probably write is just y equal to -5. The next two want me to find the domain and the range. To find the domain, I just need to know the edges of the graph. In this graph, it goes down and to the right forever and down and to the left forever. I have to extend this graph to the far left edge and the far right edge of the x-axis, and I have to extend this graph to the bottom of the y-axis. In some sense, the bottom left-hand corner of this graph is a double negative infinity point. This graph goes to the bottom of the far left of the x-axis and the bottom of the y-axis, and the right extension of this graph, it goes to the far right edge of the x-axis and the bottom of the y-axis. That's the point positive negative infinity. To do the domain, I need to know the x-coordinate at the far left edge of the graph and the x-coordinate at the far right of the graph. These are the only points I would need to worry about to find the domain, are the edges, the left edge and the right edge. The domain for this graph is going to be negative to positive infinity. In terms of the range, I can't get everything on the screen at the same time. I would need the top of the graph, which is this point 1, 4, and the bottom of the graph, and the bottom of the graph is in negative infinity. So for ranges, I need the bottom and the top of the graph. The top of the graph is the point 1, 4. I don't need that point 1, 4 for the domain because I only need the left and the right edge. The bottom of the graph would either be this point double negative infinity or positive negative infinity. If I was going to do the range of this, I need the y-coordinate of the bottom of the graph and the y-coordinate of the top of the graph. So I need one of these 2 points and that point to do the range. And in order to do the range, I go from bottom-wise, from bottom to top. And so the range of this is going to be from negative infinity to positive 4. It's the y's at the bottom, which are these negative infinities, to the y at the top, which is the positive 4. Infinities always get square brackets. Numbers on the graph, points on the graph get, infinities always get round brackets. Points on the graph get marked with square brackets. All right, just one chunk more of problems to do. And it asks me to find where graphs are increasing, decreasing, where the maximums and minimums are. So this graph, again, I don't know that it shows up so well, but I think it shows up well enough. If I'm trying to answer the question about where the graph is increasing or where the graph is decreasing, I need to mark up my x-axis with negative infinity on the far left edge, positive infinity on the far right edge, and then only the x value of where this graph is turning. So I kind of have two turning points, the point negative 1, 4 and the point 1, 0. So these 2 points that are marked, they're a maximum and a minimum point, but they're turning points. When I'm trying to find where a graph is increasing, I'm going to take the x-coordinates of the turning points, put them on the x-axis along with infinities, and create intervals with only round brackets, no square brackets for increasing and decreasing. So the numbers that I put on the x-axis, I put 2 turning points. I'm going to get 3 intervals, and these intervals, either the graph is increasing or decreasing in those intervals. This interval right here, as I'm moving from left to right, the graph is getting higher. This is an example of an increasing interval. And this interval out here, the interval from 1 to infinity, the graph is going higher as I'm drawing from left to right. So if I'm tracing along this graph, the first interval and the third interval, when I'm tracing on those, my pen is getting higher as I'm tracing on those. That would be an example of increasing intervals. So this particular graph is increasing in the interval from negative infinity to negative 1, and then the interval from 1 to infinity. The process of finding decreasing is exactly the same way. I'm going to take the turning points, x-coordinates, put them on the x-axis along with the infinities, and create intervals. And the interval where the graph isn't increasing, it's decreasing. This middle interval, as I'm tracing on the graph here, as I'm moving from left to right, my pen is getting lower. That's an example of a decreasing interval. So there isn't really any more algebra to do for it. So take the x-coordinates of the turning points along with infinities, put them on my number line, create intervals. Each one of these intervals, only with round parentheses, is either an increasing or a decreasing interval. It's an increasing interval if my pen is going higher as I'm tracing along the graph. It's a decreasing interval if my pen is going lower as I'm tracing along the graph. In terms of 19, 20, 21, and 22, 19 wants me to find the x value of the maximum. This point, negative 1, 4, because it's kind of a high point, we call that a maximum point. Technically a local maximum. I don't have room to write that. And that point 1, 0 is a minimum point. 19 wants the x value of the maximum point, which is going to be x equal to negative 1. 20, it doesn't specify it so nicely, but it wants the y value of the maximum point, which is 4. 21 and 22 do the same thing. 21 wants the x value of the minimum. The minimum point has an x value of x equal to 1. And it doesn't say y, but it implies y. 22 wants the y value of the minimum, which is y equal to 0. So that's everything for part 1 of the chapter 3, and then we'll do part 2 next week. So let me pause the video here and go load this on YouTube for you.